Everyone, welcome to my third tutorial video of chemistry in Iranian method or Persian method, but in English language. I'm very happy because our title is very interesting today. We want to talk more about the conversion mass to energy, and we want to talk more absolutely about Einstein's formula, which is E equals mc squared. But what does it mean? It tells that if we want to convert m kilogram of mass to the energy, we will have m multiplied by c squared joule of energy. The energy is E, which should be in joule, m is the mass, which should be in kilogram, and c is the speed of light, which is 3 multiplied by 10 to power 8 meter in each second. So mc squared will be m multiplied by c squared. M multiplied by 3 multiplied by 10 to power 8 square, which it will be m multiplied by 9 multiplied by 10 to power 16. So if we want to convert 1 gram of matter to the energy, so let's calculate. You will see the calculations after a few seconds in the video. As you know, 1 gram is thousandth of kilogram. So 1 gram will be 1 multiplied by 10 to power minus 3 kilogram. Then m multiplied by c squared. C, as I say, is 3 multiplied by 10 to power 8. So c squared will be 9 multiplied by 10 to power 16. Then m multiplied by c squared will be 1 multiplied by 10 to power minus 3 actually, multiplied by 9 multiplied by 10 to power 16. And at last it will be 9 multiplied by 10 to power 13. So 1 gram of matter or thousandth kilogram of matter can give us 9 multiplied by 10 to power 30 joule of energy, or 9 multiplied by 10 to power 10 kilojoule of energy. So it's the power of nuclear functions, nuclear reactions, or unfortunately nuclear bombs. As you can see the calculations in the video, I suggest you to look carefully. But now we're going to talk about something which is completely different, but it's necessary to know the Einstein's formula for the next lessons actually. Now we want to talk about something strange. As we know, an atom contains electrons, protons, and neutrons. Not always neutrons. For example, hydrogen atom doesn't have neutrons, but usually electrons, protons, and neutrons. As I say, each atom belongs to one element, and each element has same chemical properties with the other atoms of that element. So each element will have specific chemical properties. So all of the atoms of that element should have that chemical properties or that chemical property. But the atoms of one element or the same element are not always like together in physical properties. For example, density or weight. If you wanna weigh all of the atoms of magnesium in nature, they will be different in the weight. Some of them will be, for example, heavier and some of them not. It is for lithium too. So why? As I say, we have electrons, protons, and neutrons in the nucleus and in the atom. So what is the reason of this difference in physical properties or in density in weight? As you know, the chemical properties go back to the electrons. And electrons are related to protons. So we can say that each atom has same number of protons, and all of the chemical properties actually depends on the number of protons and electrons. So the same atom of one element cannot have different numbers of electrons and protons, because then their chemical properties will be different and they will not be one element, they will be different elements. So the reason of this difference in the weight and physical properties must not be the same reason for chemical properties. We must do something in the atom which actually give us the same chemical properties but different physical properties. As you know, the chemical property does not depend on neutrons. So the atoms of one element can easily have different number of neutrons. Neutrons are not like proton and electrons, and the chemical property does not depend on them and does not depend on it. And so the atoms of the same element can have different number of neutrons. We call these atoms isotopes. Isotopes are the atoms which have the same number of protons. We call the number of protons the atomic number. So, for example, it has 5 protons, its atomic number will be 5. So, they have the same number of protons, the same atomic number, the same chemical properties, the same number of electrons, but the different number of neutrons, different mass, and actually different weight, and different physical properties such as density or weight. We have a word which we call it mass number, like atomic number. Atomic number is only the number of protons, but mass number is the number of electrons plus, the number of protons plus the number of neutrons. So the atomic number should only depend on the protons, but the mass number depends on protons and neutrons. So then, if two atoms of one element have the same proton numbers and different neutron numbers, they will have different mass numbers, even they have the same atomic or proton numbers. These isotopes, as I say many times, have different neutron numbers and different mass number, but same chemical properties, same electrons, and same protons. The interesting part is that, for example, for lithium, we have 2 isotopes for lithium. Both of them have actually, of course, have 3 protons, but one of them have 3 neutrons, and the other one has 4 neutrons. So they're the same in the numbers, in the number of protons. They're all 3, but they're different in the number of neutrons. One of them has 3 neutrons, and the other one has 4 neutrons. So the atomic number will be 3 for both of them, but the mass number will be 7 for one of them and will be 6 for the other one, because 3 plus 3 will be 6, but 3 plus 4 will be 7. The interesting part for me, and I hope you, is that you can't find the number of these elements or the number of these atoms like together in the nature. What does it mean? It means that, for example, for the lithium, as I can see in my book, 94% of the atoms of the lithium will have 3 protons and only 4 neutrons. But only 6% of them have 3 protons and then 3 neutrons. So their number of their atoms are different. For example, some of the kind of isotopes with 3 protons and 4 neutrons will be more than the other one, which has 3 proton and 3 neutron. We call the number of the atoms the fractional abundance. So as I can say, they're different in the number. Isotopes are different in the numbers. I can say they have different fractional abundances. Fractional abundance means the number of each isotope of one element. So I can say the fractional abundance of lithium isotope with 4 neutrons will be 94% actually, and the fractional abundance for the lithium isotope with 3 protons and 3 neutrons will be just 6%. And it's the difference between isotopes. So please repeat with yourself what is the meaning of isotope and why are isotopes different, where are isotopes like together, for example in chemical properties, and just try to solve some problems with the Einstein's formula E equals mc square. M kilogram of matter will give us m multiplied by 9 multiplied by 10 to power 16 joule of energy. And then just take care, and if you want to learn more about the isotopes, about the radioactive properties, just do not hesitate to follow my next video. Take care.